Hi, this is Albert from AWB Electrical. Just doing a little bit more of a FYI and a how-to on accumulator tanks. So just here on I think it's a 65-foot fair lane, and they were having a bit of pump problems. And when I went through and checked this, the accumulator tank, which is underneath this, so normally when you buy these Jabsco units, it actually comes as a package unit with this pump, and an accumulator tank inside here. So this was displaying symptoms of low pressure and not very good flow, which normally indicates one of the pumps is dead, which in this case the bottom pump was dead, and you can tell because one of the fuses was blown, and when you turn it on and off, especially at low flows, you could hear the pump cycling in and out. So that was telling me there was two different symptoms happening there. So the low flow and low pressure is an indication of the pump. The pump cycling at low flow is an indication of an accumulator tank fault. So on this accumulator tank, it's got a Schrader valve here. Most of them do, like this one here. Just throw this one out, and there's one there. Okay, so these accumulator tanks, as a general rule, you should be testing them at minimum every 12 months with no water pressure. That's zero water pressure in the system, because if the accumulator tank's faulty or not, if there's pressurized water or a pressurized hydraulic system, this will show the hydraulic pressure. So if this system's running at 3 bar and this accumulator bladder is ruptured or not, this will show 3 bar. The only difference between showing 3 bar with air, 3 bar with water, is when you push this, water will come out if the bladder is ruptured. Which in this case here, this one here, the old one, the bladder was ruptured, it had a pinhole in it, and when you pushed on the Schrader valve, water came out. So that straight away tells you the accumulator tank was not good. I split these Jabsco. Sometimes you can get the bladder for them. This one I couldn't get a bladder, and we just needed to get it fixed, so I just got a brand new accumulator tank. When you install an accumulator tank or test the accumulator tank, as I said, apart from testing it with zero pressure, you generally always pressurize it to just below the kick-in pressure. So on this system here, one of the pumps is supposed to kick in at 25 psi and one of the pumps is supposed to kick in at 40 psi. So Jabsco says 2 psi below, but generally I work on 1, so this here should be about 24, 23 psi. You should be seeing here with zero pressure in the system. So that means pump's isolated, the system drained out, and there's no residual pressure in there, and when you open the taps there's nothing there, and you got 23 psi here. This one would be the minimum pressure you would see probably on this Khalifi valve setting on the side here. If these were set on a VSD or VFD system or variable speed drive system, whatever the set point of the motor or pump system is, you set these at about 70%, 70% of the set point, and they'll put you in the ballpark. Accumulator tanks are not so critical on VFD drives compared to fixed speed systems. For VFD drives, it's just to give a bit more elasticity in the system, especially when there's a lot of hard pipes. With fixed speed systems, it's to give it recovery time for when the pump cycles on and off. So technically speaking, the actual theoretical rule of thumb is this tank here. This is only a 1 litre tank, but normally you would size it to be 1 litre for every minute of flow of your system. So this system here is, it's hard to see there, it's not zooming in correctly, but this system here is rated at 28 litres a minute. So if you're sizing this correctly, you'd have a minimum of about a 30 litre accumulator tank below here. But typically these Jabsco systems are very small accumulator tanks. The reason why you size it for 1 litre of flow per minute is because when the pump stops, you want to give recovery time for the pump to cool down, settle down, where the accumulator tank allows it to do that, and then when the pressure drops to the point it kicks in, the pump's had a rest, and then it can restart again and run again. Because if your pump's cycling on off, every time it starts, it has an inrush. That inrush creates heat, and then you need run time for the pump to dissipate that heat. So the cycle time's too quick, you'll burn the motor out in the pump. And probably most likely what will happen is this pump here burned out because the accumulator tank failed. So normally what will happen is most times a pump fails in an accumulator tank system, especially a variable flow system like this is with all taps throughout the boat. So this has like 2 toilets, 2 bathrooms, a kitchen, and all the toilets are fresh water and so forth as well, and the showers. This will have varying flow rates. So with all the varying flow rates, the pump will range from flat stick to basically cycling on and off. And that cycling on and off is not helped when this accumulator tank is basically not right. So this is very important to do your maintenance on this, minimum every 12 months. You should be testing these, 1 psi or 2 psi. It's not really going to break the bank, getting that slightly out, below the kick-in pressure of what the pressure switch is, and ideally 1 litre per 1 litre a minute of flow. So a 30 litre a minute flow system, you'd have 30 litre accumulator tank. Some's better than none, but yeah. And then 70% of your VFD drive setting if it was a VFD drive, which this is not a VFD drive. So hopefully that helps someone out there with accumulator tanks, because they're normally an overlooked thing, especially with this here, with this sitting underneath here. It's kind of out of sight, out of mind. And a lot of people don't realise these caps here are actually Schrader. They're actually for the Schrader caps. So most people think that's like a bump cap or something. So hopefully that's helpful. Thank you very much. Have a good one.